we're going to talk about vectors in space. So it works very similar to how we talked about vectors before, but now we're in 3 dimensions. And so if I write down the component form of a vector, it would have 3 entries. And we have 3 standard unit vectors. In this case, we have I, 1, 0, 0. We have J, which is 0, 1, 0. And then we have K, which is 0, 0, 1. And I can write any vector in standard unit vector notation, which would look like v1i plus v2j plus v3k. If I'm given a vector with an initial point P, so this point would be P1, P2, P3, and a terminal point Q, Q1, Q2, Q3, I can write the vector PQ. Again, this works very similar to what we saw before. You take the terminal Q1, subtract the initial Q3 minus P3. Just have 3 entries instead of 2 now. Okay. And I can tell if 2 vectors are equivalent if and only if in component form the entries have to match up. U1 equals V1, U2 equals V2, and U3 equals V3. And lastly, the magnitude of a vector in space is V1 squared plus V2 squared plus V3 squared square root. So again, this is very similar to what we saw before. We're just now working in our 3-dimensional space system instead of just the 2-dimensional coordinate system. So let's look at a problem involving vectors in space. Let's find the component form and magnitude of the vector V having initial point -2, 3, 1 and terminal point 0, -4, 4. Then, once you're done with that, I want you to find a unit vector in the direction of V. So let's start with the first thing we're asked to do. If I find the component form of this vector. So let's start with that, this vector V. And if I look, you're going to take a terminal point minus your initial. So to get our vector V, we take 0 minus a -2, so 0 plus 2, -4 minus 3, and 4 minus 1. So this vector would be 2, -7, and 3. So there is my component form of my vector. Now we're asked to find the magnitude. So let's find the magnitude of this vector. The magnitude of v, using our formula, it's the square root of 2 squared plus negative 7 squared plus 3 squared. It's the same as square root of 62. So there's my magnitude. Now the last thing I'm asked to do is find a unit vector in the direction of v. So we know how to find that unit vector. What I do is it's a scalar multiple, 1 over the magnitude of v times the vector v. So I know the magnitude, it's the square root of 62, 1 over the square root of 62 times my vector v to negative 7, 3. And then we just do our scalar multiplication, essentially by distributing 2 over the square root of 62, negative 7 over the square root of 62, and 3 over the square root of 62. And there's my vector, my unit vector in the direction of v.